Today we're talking about Natural Wonders Chapter 5, which is all about sedimentary rocks. And before we get into the individual rocks, just like last time, we have several paragraphs with some really key information that helps us understand how these rocks form. So let's look at those paragraphs and let's take some notes. In the second paragraph, we start seeing the different types of sedimentary rocks. There's three main categories. One of those categories is clastic sedimentary rocks. And clastic sedimentary rocks are the majority, the most common group of sedimentary rocks, and they're made out of pieces of other rocks. So small bits and sediments get shoved together and cemented together and they form a new rock. That's a clastic sedimentary rock. The second group of sedimentary rocks is chemical. And chemical sedimentary rocks form through evaporating water. So when ocean water evaporates and it leaves behind precipitated salt, that is a form of a chemical sedimentary rock. And the last group of sedimentary rocks is organic. And these rocks are made out of the remains of dead organisms. We're talking about shells and skeletal remains that are packed together and cemented, and they can form layers of rock, sedimentary rocks. Although there are three different types of sedimentary rocks, most sedimentary rocks form in the same way. So there are 4 steps in the process of forming the majority of sedimentary rocks out there. The first step is weathering. Weathering might be a word you've heard of before, and it's simply just the breaking down of a rock from a big rock just to smaller pieces of itself. The next step is transportation or erosion. And erosion is just the movement of the sediment either through water or wind or glaciers until eventually we get to step 3, which is deposition. Deposition is where that movement stops and the sediment is now resting. And it allows step 4 to take place, which is lithification. Lithification involves 2 parts. We have to first compact sediment together, so this can happen just with overlying rock layers. More sediment put on top will squeeze the layers at the bottom. After it's compacted, it also needs a cement to hold those sediments together. The cement is normally just precipitated dissolved elements. So groundwater flowing through sediment can leave behind elements that the water was carrying and fills the space between sediment. When the space between sediment is full, those sediments are now glued together. That's lithification. Now that we have that information out of the way, we can get to the rocks. The first 4 rocks that we're going to be looking at are clastic sedimentary rocks. So these are the rocks that are made out of pieces of other rocks. And 2 important parts of identifying or labeling these rocks is going to be the size of the sediment and also the roundness of the sediment, how round they are. It actually matters. It does. It matters. So the first rock starts with gravel-sized sediment. And the first rock we're looking at is conglomerate. It's important to know for these first 4 rocks, the environment these rocks indicate. When you see a sedimentary rock, you know that sometime in the past, what environment must be exactly where you're standing. And when you see conglomerate, layers of conglomerate, there's 3 options. They're all in your packet. Underline these. Things like rough water, fast-moving rivers, or shorelines. Those are the environments that are indicated when we see conglomerate. And it's important that you not only see the size of the sediment here, but also the roundness. You have to see how round each grain of sediment is. The more round a piece of sediment is, that indicates it traveled a longer distance. So when it's really round, it means it has bounced on the ground in a river many, many times. If they start out angular, like a dice, and you roll a dice across a table, the dice bounces on those angles and corners. So if a rock is bouncing on its angles and corners, they're eventually going to be rounded down. So conglomerate means that it has traveled a long way. The second rock is breccia. And what we're looking for in breccia not only is the size, because again this is gravel size, but also all of the angles. When you see the sediment here, you can see that there are flat surfaces and points which represent a very short transportation erosion period. And then it gets lithified together. Breccia does not have environments listed, but it would represent the same exact environments as conglomerate. When you see breccia, it's going to be rough water, fast-moving rivers, or shorelines. As we decrease in sediment size, we get to sandstone. And sandstone obviously is made out of sand. So this is a smaller sediment size. It doesn't say an environment in the packet, but if you think about it, where do we see a lot of sand? The beach, so also shorelines. Potentially dune environments or deserts could also produce sandstone. Our last clastic sedimentary rock is shale. And shale is made out of the smallest sediment, clay-sized sediment. And that clay can only settle in very calm water, like deep ocean, far off from the shore. Underneath the waves that stir up the ocean is actually very still and calm. There are 3 environments it could potentially indicate: calm water, oceans, and lagoons. The next rock we're going to look at is limestone. And limestone is a chemical sedimentary rock, meaning that it forms through the evaporation of ocean water. And it produces calcium carbonate, CaCO3. And the cool thing is about calcium carbonate is that it reacts with acid. So if you put a drop of hydrochloric acid on the surface of limestone, it's going to fizz. And actually it releases carbon dioxide. Those are the little gas bubbles that fizz out. Another chemical sedimentary rock that we have is Dolostone. And Dolostone is kind of limestone's cousin. Dolostone forms when there's a chemical substitution that takes place. It starts out as limestone, calcium carbonate, but the calcium is actually removed and replaced with magnesium. It's about the same size and the same charge, so the substitution is pretty easy. But that changes how Dolostone then reacts with acid. If you put a drop of acid on the surface of Dolostone, it doesn't fizz. But if you use a knife and scrape up the surface to make a powder, the powder will fizz with Dolostone. And that's just because as you scratch the surface, you're exposing some of those left behind calcium carbonate, and that's what's going to react with the acid. The very last rock that we're going to look at is an organic limestone. There's 2 samples here. Both of them are made through skeletal remains, shells that are lithified together. That's going to wrap it up for chapter 5. If you have questions, please make sure to ask. Otherwise, good luck studying, and I'll talk to you later.